In this video, we're going to be testing the claim about a mean where sigma is unknown, and we're going to be using the critical regions method. This is the formula for the test statistic. We're not going to be using this formula. We're going to be using a calculator, but if you want to use the formula, this is what you would use, and this is what each part of the formula means over here. Make sure you know what DF stands for, degrees of freedom, because that is important regardless of whether you use a calculator or not. So in this example, a simple random sample of 40 recorded speeds in miles per hour is obtained from cars traveling on a section of I-10 in Texas. The sample has a mean of 68.4 miles per hour and a standard deviation of 5.7 miles per hour. We're going to use a 0.05 significance level to test the claim that the mean speed of all cars is greater than the posted speed limit of 65 miles per hour. So we're going to be using a 0.05 significance level. So we know that our alpha value is 0.05, and we are testing the claim that the mean speed of all cars is greater than the posted speed limit of 65 is greater. So that's the big thing here. So in setting up our hypothesis test, we know that the mean is going to be equal to 65 for 65 miles per hour, and that our alternative for our mean is greater than. So we're going to say greater than 65 miles per hour. Now we need to find our test statistic and our critical value. So we can find the critical value from our alpha value, our alpha being 0.05, and that our degrees of freedom comes from the fact that we have 40 recorded speeds. That's our n value. N equals 40. So our degrees of freedom is one less than that. So we're going to have 39. And this is also a one-tailed test because it is greater than. So it's a right-tailed test. So we can go to our table for our critical values here. And we know it's a one-tailed, so 0.05, fourth column. And our degrees of freedom is going to be 39. So if we go down, we're going to see that it actually skips 39. It has 38 and 40, so neither is closer than the other. So we're over here, we see that it is 1.686 and 1.684. I'm going to split the difference as it's right in the middle and say this is 1.685. So our critical value is going to be 1.685 for T. So we still have to find our test statistic. So I'm going to go in and use a calculator to do that. So bring up my calculator. And I'm just going to go to Stat Tests, and I'm going to do a t-test. And so I have a bunch of statistics, so I'm going to go to Stats, hit Enter. And so I have a mean right here that says 65. So I'm going to type in 65 for the mean. And then for our other mean, it says a sample of 68.4 miles per hour. So that's what's going to go in for my X bar, 68.4. Then our standard deviation right here of 5.7 miles per hour is going to be our S. So 5.7. Our N is 40, we have from before. And then our alternative hypothesis is greater than, so we're going to go down here and select greater than, and then calculate. And that's going to give us a test statistic of 3.772. And we can round it up to a 3, so 3.773. So our T-stat, our test statistic, is going to be 3.773. Now, if you were using a calculator to find the critical value, since I do not have a TI-84 program, what we're going to do, or what you would do if you want to do that, is you would go to second vars, and you would select inverse t. And for area, you would select 0.05. And then for degrees of freedom, you would select 39. Now it's going to come out as a negative number, but since our hypothesis is supposed to be right-tailed, you would just select it or change it from a negative to a positive number. But this is what you would do if you have a TI-84. Just follow these steps and you would get the same critical value here. So now that we have our test statistic and our critical value, we can use the critical regions method to see whether we reject it or fail to reject. So our critical value is what we're going to do for the critical region, and 1.685 is I'm going to just kind of eyeball it, zeros in the middle, and I'll say it's right here. So 1.685, and since it's right-tailed, I want everything shaded to the right. Now this is where our test statistics comes in. We're going to test it. 3.773 is going to be somewhere, I'll say, here, but it's definitely in the shaded region. So since it is in the shaded region, it's in the rejection region, we reject the null hypothesis. Now that we have rejected it, we still have to state our claim. We have to kind of summarize it in a sentence or so. So I'm going to go here, and I'm going to write out my statement. Since we rejected it, we say there is sufficient evidence to support the claim that the mean speed is greater than 65 miles per hour. And remember, the claim is that the mean speed is greater than that. Since we rejected the null, we say that there is sufficient evidence to support the claim that it is greater than. So this is the rejection region method, the critical region method for finding whether you reject or fail to reject.